Hello and welcome to this introduction video to the Candela platform, the cloud platform for Copernicus Earth observation data analytics. In this video, I will give an overview of the platform, explain briefly how the components interact between each other, but mainly I will make a demonstration of the utilization of the platform. The platform runs on the Cloud's cloud infrastructure, which provides us with computational resources and a direct access to Copernicus Earth observation data. On top of this infrastructure, we have deployed a Kubernetes cluster and a distributed file system. Kubernetes is an orchestrator that will provide each component its resources and allow them to communicate between each other. Two types of modules run on the Kubernetes clusters. We have called them here component and Candela building blocks. Components are mainly of the shell software and run permanently. For example, we have GeoServer, the Jupyter Hub, some databases, the monitoring, etc. Candela building blocks are algorithms developed for the Candela project. They are executed by the users. The user connects to a Jupyter environment where he can prototype new services or develop use case applications. When a user logs in, a new Jupyter instance is created for him with dedicated computing resources, access to its personal data, and access to Earth observation product. From Jupyter, the user can access to the computing engine who expose a WPS standard interface to run geoprocessing tools. These tools are mainly the algorithms developed for the Candela project. The user can launch several processes in parallel. Each process runs with dedicated computing resources provided by Kubernetes. This parallelization mechanism allows the user to process large amount of data. The monitoring component constantly controls the state of the Kubernetes clusters. If the cluster runs out of resources, it is not able to launch new applications or services. Before reaching this state, the scalability component triggers the creation of new virtual machines, allowing Kubernetes to schedule more services. When a user logs in, he accesses to a Jupyter Lab environment. In this environment, he can create new notebooks, execute Python code in the console, or bash commands in a terminal. The access to a terminal allows him to install new Python packages if needed. In the file browsers here, we have three folders. Lib, which contain Candela dedicated libraries, Public, which is accessible to everyone, and Work, which contain the user's personal data. In the public folder, we have several subfolders containing notebooks examples for different use cases. These folders are read-only. There is also a shared folder where anyone can read and write. It is used to exchange data between users. I will now open an example notebook. Okay, here in Work, Demo. This notebook contains illustration of the use of libraries we developed in Candela to help the user. So first thing we want to demonstrate is how to launch processes in Candela. So first we have to import the WPS lib library and the JSON library just to print some result. The WPS lib library contains a method called getCapabilities, and this getCapability method will return the list of available processes in our GeoServer. So if I execute this, okay, and now if I print the capabilities for Candela, we have this list of processes. So for each process we have the title and an identifier and an abstract. WPS lib also allows to have a description of a process parameters. This is done by invoking the getProcessDescription method. Okay, so if I execute this method with the parameter Candela IO miner processing with which is a process identifier, I will get a description which is a JSON description, so I can print it, and here I have all the names of the parameters for this process, and a description, and if it's optional or not. So next we have to set up the parameters for the process before invoking it. This is done by creating this list of couple. Each couple is a name of a parameter and a value. So the value is here in some variables defined just before. And once I have defined all my parameters, I can invoke the WPS lib run single process method with in parameters the identifier of the process I want to launch and the input mainly. Next, the output are rarely used, and WPS logger is just if we want to have some information printed out when the process is running. I will not launch the process right now because it takes a long time, and I think you will see this in other demonstration video. Other methods are available in the WPS library, for example, to launch processes in parallel, and among other things. I will now present the Curious library, which is used to search for Earth observation product in the Curious catalog. So first I will import the Curious library. And first thing we want to do is to know which are the research parameters available. So we have a method for this called the display collection parameter. So this method will print out a list of parameter name and the description. So this is all the parameters available to search in the Curious catalog. So for example, I can, and with a search method from the Curious library, I can use any of this parameter name. I just have to give the name of the parameter and then give the value I want to search. So here, for example, I want to search for Sentinel-2 product. I will give a bounding box with some coordinate and just start date and a completion date. So let's execute this command. It will search for results. So yes, it has found a lot of results. We have a method to display just the identifier of the product, and yes, this is displayed in this tab. Okay, so I've got really a lot of results, and let's say I'm just interested in only one Sentinel-2 tile. It's very long. Let's say I want to filter this result to only have the tile 31 TDK. So I can apply a filter on this list of products, and the filter is mainly a regular expression that is evaluated against the identifier of the product, and I can have a list of regular expression, and each product that match at least one of the regular expression in the list will be written in a new list. So here I will just select the 31 TDK tile, and I will have a much smaller result list with only this one tile I selected. Okay, we can look at what is contained in the description of a product. So we will look at this just in the first element of the list. And here we have a lot of information, the name of the collection, for example, the product identifier, which was displayed here in this list, the title, what can we have, the thumbnail that can be displayed, the start date, completion date, and also I think at the end we have the footprint of the product. So a lot of information available for each product. The Candela library has a lot more method to search for product. It also has method to create symbolic links to selected products in the user workspace. These links can be used as parameter for processes. I will now talk about the visualization library that we have developed. It is basically a library based on IP leaflet, and it is used to display information on maps inside the Jupyter environment. So I can import these libraries, and I will make a new research with the Candela theme, with a much bigger area, but with a smaller time interval. So I have only 31 product, and I want to see where this product are situated on the map. So I can give my result to this method, getMap for preview product, and when I execute this method, I will have a map object called here M. I will just increase the size of the map and ask it to be displayed. So here I've got my map, and this map will display all the thumbnail if available, and if the thumbnail is not available, it will always display the footprint of the product. So in blue you have the footprint, and next you have the thumbnail image. Here we have the list of the different image displayed, and we can unselect some of this image, and we can see them disappear. So the thumb is a thumbnail, and where there is no underlined thumb, it's just the footprint. So this can be used to select an image on a certain area. In this last example, I want to demonstrate how we can display results on a map. So here I have two GeoTIFF images generated for different Earth observation product, and I want to display them on a map. So we call getMap for GeoTIFF, which will generate a WMS layer in GeoServer from these two images, and I will ask to IP leaflet to display those two layers. So they should be shown right now. Okay, here they are. So if I zoom in, first the resolution should not be great, and yes. Next, the IP leaflet will ask the WMS layer for a higher resolution, and the more I zoom in, the higher resolution I will get technically. Okay. So this is it for this demonstration.